Hey guys, in today's video we're going to be working with the Ender 3 V2, and this particular machine is running the stock 4.2.2 board, Raspberry Pi 3, and a couple of buck converters. It's running Clipper and a few other upgrades to the hot end assembly, the Y-stepper housing, the build plate surface, and then as you can see in the video here you got the squash ball feet. And what we're going to be doing today is installing the Manta M5P. If you followed the previous video, I talked about a new way of installing and flashing Clipper onto the board, along with a basic printer profile. Well, today we're actually going to put it in the printer. So, guys, if you're new to the channel, consider subscribing, turn on your notification bell, and leave me some comments. I love reading the comments and do my best to get back to you guys as soon as I see them. All right, guys, so let's get started. I just want to show you what we're going to be doing here today. So I got both the new Manta M5P here, and then this is a stock 4.2.2 board. And you can see that there's a significant size difference between these two. Not only is the footprint of the overall board bigger, but then you also have the height. There's a big difference in how tall these things are. So you can look here at the profile. So I had to redesign the original enclosures that I had made for the Raspberry Pi, along with a new housing for the stock 4.2.2 board. And what I essentially did is make this much taller than the footprint of the original housing that came with the printer. But because we have the squash ball feet, which you can see just to the right here, we can extend the thickness of these cases and still have enough clearance for the fans and everything else to work properly. So let me go ahead and strip this machine down, take it all apart, and then we'll replace these narrower housings for the deeper ones that will fit the Manta M5P. All right, so I'm just gonna set this thing on fast forward, and you guys can watch that process. Make sure you start by unplugging your printer from the power supply. And I'll leave links to my Shopify store if you guys are interested in doing this upgrade to your printer. That way you guys can pick up the STL files. All right, so the way the housings hold on is using, so they have this rail guide here that goes into the extrusion, and then it gets bolted down using these two holes here. It grabs the 40x40 extrusion in the middle using a couple of T-nuts and some 5mm Allen bolts. To mount the Manta board, I'm just using some M3 by, these are a little M3 by 6 millimeter, so they're real short. I think I changed my mind about the buck converters. I'm not going to put them in. But anyway, this bottom enclosure is going to have a couple of standoffs here for a couple of buck converters. And one thing that I noticed with my previous design is that the buck converters, sometimes the distance between this screw hole and this screw hole is either wider or narrower. So what I did is I created this slot on one side. So you anchor the first screw down on the buck converter, and then this one has like a wide slot where you can screw down where, you know, wherever the position is of the screw hole on the buck converter, it should be able to fit into some position in this slot. All right, guys, so I got the thing all wired up, and I wasn't going to bore you to death with watching me wire this thing. But the way that I found to get the cleanest wiring, or at least the way I did it, is I wired from the individual plugs back. So, you know, I was able to organize the cables, and then as I got to wherever it is that they needed to wind up at, then I would just clip it the appropriate size, put the connectors on it, and plug it in. As opposed to doing it the way that they do it from the factory, which is the opposite. They start from the ends, and then they wind up with all this extra slack over here, and that's what makes it a mess on this side. So anyway, I like the look of this better, and it helps me to be able to point out different features of this board more easily to you without having cables in the way. So let me get in close here. So this is an Ender 3v2. Let me get in close here so that I can show you guys exactly how I wired everything. So we'll start with the bottom. Let's see if I can arrange this. Okay, that looks good right there. I'm gonna turn on this camera here, or this torch here. I'm not sure if the torch helps or if it messes thing up, but okay. I guess it's not that bad. Let's try to get a little bit lower so maybe we can see the labels of the. You can't see those labels. All right, probably over here is going to be better. That's probably pretty good right there. All right, I think this gives us a pretty good view. I'll zoom in a little bit. Okay, so when you're going to set these things up, this is the order of the stepper drivers. So the very first one here, so this would be, if you look at the board, it's got the plugs. All the plugs are along this side over here. So along this front edge here, that's where all the ports are. So the very first stepper driver is your X, followed by Y, then Z. And this board comes configured with this fourth stepper driver as the extruder stepper driver. And then this last one is labeled extruder 1, or like the secondary extruder. But really it needs to be, they need to be flip-flopped. Okay? And the reason that I figured that this is the way that it should be is because this last end stop, this last stepper driver does not have an end stop. This only has a thermistor port. So this thermistor port coincides with this last stepper driver. There is no end stop for this one. So in my mind, this one should be the extruder stepper. Why you would want to have this as something other than the extruder stepper, I don't know, because it can only work as an extruder stepper because it has no end stop. Now, the one that they originally had as the extruder, um, I'm using it as a second lead screw or independent lead screw control. And to do that in Clipper, you label it Z1, and that's the way that I have it configured. As far as the end stop goes, I'm using a CR Touch, so my end stops are virtual for both Z accesses, and I'll explain what these end stop plugs are being used for. So in the Z1, or my second lead screw end stop, instead of using a physical end stop, I'm using this as the filament sensor port. So when my filament runs out, it triggers this, and all I do is tell Clipper that, hey, whenever this pin gets triggered with, that means that the filament ran out. And that's easy to do in Clipper, and I'll show you that later on. The third stepper driver is my Z, and I am using a virtual end stop, so really this one shouldn't have anything plugged in here. But I'm having this kind of a strange issue, and I'm not sure if it's limited only to my board, or if this is just something that I haven't been able to figure out what the cause of it is. But when I have this Y end stop connected to its proper place off of this Y stepper motor driver area, it will not trigger if the X is triggered. And on the Ender 3 V2, when the X is in its home position, it's triggering the end stop. And what was happening to me is when I tried to home everything, the X would home and trigger, and then it would initiate the Y to home, but it would never trigger, despite the fact that the trigger switch was depressed by the bed. It would just continue to run and skip the belt, and it would never trigger. And what I found is that for some reason, when this one is triggered, you couldn't trigger the Y. Why that is, I have no idea, but in my case, that's what it was. As a workaround, what I was able to do, since this third stepper motor end stop was vacant, I designated it as the Y end stop trigger, and that's easy to do in the printer.cfg. You just change the pin assignment. So you just say, okay, this pin now belongs to Y, and it's as easy as that. So now everything works as it's supposed to. X can trigger and stay triggered, and then the bed will move, trigger the Y limit switch, and then the last thing would be the Z would then initiate its movement, and then the CR Touch would probe the bed, and then that's it. So the homing sequence is done. But anyway, I just thought I'd point that out because I was having that problem, and I thought it was very strange. But in my case, that's just how I solved it. All right, so let's get down to the motor plugs. So the very first one, let me move you guys up a little bit, point this thing down so maybe you can see the labels. Possibly see the labels. All right, so let me roll this one around so you can see. Okay, so this first port is X. So that plug goes to my X stepper motor. The next one is labeled Y. So this next one goes to my Y stepper motor. And then the third one is labeled Z. And this one controls my left Z axis stepper motor. And then the vacant port next to it is essentially a second output for this third stepper driver. So if you wanted to run dual lead screws, but you don't necessarily need independent control of that stepper motor, you can use this port here. Following stepper driver that I have labeled Z1, this one does allow independent control of the second stepper motor, and then it also has its own port here. And then finally, you got the extruder stepper driver and the extruder stepper port. And to fasten these cables, I've had somebody ask me recently about this. So all this is some telecommunication jumper wire. And I'll show you what it looks like. It looks like this stuff right here. You can buy this on Amazon, I'm sure in rolls. And all I did was use one of the strands as kind of like a makeshift wire tie. What's nice about using this instead of a standard wire tie is that you can reuse them. So if you need to make a change here, instead of clipping off and wasting a wire tie, you can just undo this and then just retwist it. So if you notice here on the one over here, all it is a little twist. You can kind of see it peeking out here. See if I can push it up so you can see. See, all I did was just twist that little wire there, and then you can pull it down and kind of hide it so you don't see the twist part. And this makes organizing your wires very easy, and it looks really nice in my opinion. Okay, so let's get here. Let's look at the stuff in the middle here. So these two ports up here, these are for your display. So if you were running a ribbon style monochrome display similar to what you would see on an Ender 3, you can use these ports here. So either these ports are designated display port outputs, but primarily for these monochrome displays. You might be able to use it for an Ender 3 on an Ender 3 V2 display, which is a color display. However, I have not tested that. These two ports over here are labeled RGB1 and RGB2. So if you want to have LED lighting in your 3D printer enclosure or on your 3D printer, these two ports can be used for that. And then they can also be controlled via the printer.cfg. This top port here with the 5 pins, this is the CR Touch port. So one thing that I came across is that the color wires on these CR Touch and BL Touches, they don't necessarily match with the output of the board. And I'll show you in a second what I mean by that. So if you look at this cable here, this is my stock connector for my CR10S Pro V2. This is the one that was connected to the BL Touch. And if you notice, if you look at the colors, how they match up to the one that I have on the board, the bottom series matches, but these two top wires are reversed. So if you were going to wire your own CR Touch on the other end or BL Touch on the other end, and you are using these wires as a guide, you will probably mess up your CR Touch or BL Touch because you would be putting voltage in on the sensor wire, which is this blue wire. So that's why it's important to go off of the documentation and verify that your colors match up the way they're supposed to match up. Because if you try to custom wire your own cable, you'll probably run into issues. But now the other end of this wire, if you look at the other end of this wire, they follow the same sequence. So the reason that this doesn't have a problem, so I could actually take this plug it into any board that has a CR Touch on it, and it will work just fine. Because pin 1 is going to pin 1, pin 2 is going to pin 2, 3 to 3, and so forth and so on. The colors really don't matter because the right signal is going to the proper pin. Where you run into problems is if you're trying to wire your own stuff up, what is visible on one end is not necessarily what goes on the other end. All right, so we got that out of the way. So now let's look at this thing here. So this port over here, next to the CR Touch and BL Touch port, this is an induction port. So if you're using an induction sensor, you would use this port. But what's interesting is that these jumper wires that are underneath it, this jumper right here, in the instruction manual, it lumps this jumper in with the fan control. But this jumper has nothing to do with the fan control. This jumper has to do with the voltage that you would get for your induction probe. So this very first set of pins will give the induction probe whatever the input voltage is of the control board. So if your control board has a 24-volt power supply powering it, it's going to give 24 volts to the induction probe if you use this set of jumpers. If you use the following set of jumpers, the middle pins here, you jump them together, then your induction probe would get 12 volts. So this has a resistor on the board that steps down that voltage to 12 volts. The final set of pins down here, these two pins, this would give the induction probe 5 volts. So depending on what kind of induction probe you're using and what type of voltages it requires, would determine where you set this jumper on. So since I'm not using an induction probe at all, I'm going to go ahead and pull this little jumper out of here. I initially put it in there thinking that had to do something to do with the fan, but it does not. This has nothing to do with the fan control. This is only for the induction probe. All right, so this one is labeled fan 1. And it's also labeled just above this plug. It also says fan 1. And this particular zoom in here enough so you guys can see. So what I'm using for this hot end fan is an Noctua, and it's a 12-volt Noctua, and that's the reason why I have this jumper set on this middle set of pins here. Okay, this will reduce the board voltage, which I have coming in as 24 volts, down to 12 by using these two pins. And if you wanted to use a 5-volt fan, then you would use these two bottom pins here. Okay. If you were using the stock fan, then you would set the jumper up here, and then that would give you whatever the board input voltage is as an output for this fan. So in my case, again, 24 volts. If I was to move this jumper up, there would be 24 volts coming out of this voltage side of this plug. All right, so let's move over to the next one. The next one is the parts cooling fan. Again, on the parts cooling fan, I'm just using some standard 4010 blowers. They're 24 volts, and that's the reason why I have the 24-volt jumper in here. If I was to use a 12-volt fan, then again, I would use the middle set of pins. If I was using a 5-volt fan, then the bottom set of pins. These are the only two fan ports. So they're labeled fan 1 and fan 0. These are the only two that you can determine the output voltage by changing these jumpers. These other two ports over here, this one and this one is labeled pi fan, and this one is just labeled fan. But both of these get their power from the board input. So again, if the board input is 24 volts, both of these fan ports would give you 24 volts out. So what I'm using here for this, I'm using this fan as my my cooling for both the boards, and I'll back out in a little bit so I can show you that. But that's what I'm using this port for. And then lastly, over here you have the heated bed thermistor, and it's labeled TB. Change the angle so you guys can see it. See that right there? This is labeled TB. This is the thermistor bed. That's what the TB stands for. And then if I didn't mention this before, here you got thermistor 0, which is extruder 1, which is this one over here. Thermistor port 0 is thermistor port for this last stepper driver. And then the thermistor port, so this is thermistor hot end 0, thermistor hot end 1, or your flexible stepper driver, which is this fourth one. It's vacant because I'm not using it as as an additional hot end. I'm using it as a Z stepper motor. All right. This first set of pins. So this is your voltage side. So this is positive. Is this so second from the bottom is positive, and then negative is next to it. And I'm coming straight off the power supply, straight off the 24 volt power supply to give the stepper drivers 24 volts directly. And I set my board up this way using a jumper wire. If I had not set that jumper that way, then it would get whatever the voltage input is for the board, but it would give it to the stepper drivers after the board uses its power. So I thought it would be more efficient to power them directly, and that's the reason why I did it this way. This next set of ports here that doesn't have anything in it, this would be, again, if I was using this flexible stepper driver as a secondary thermistor, then I would need the hot end cartridge wires would go here. But since I'm not using it that way, this is vacant. The one above it here, these two, this is for the hot end. So this is for the heater cartridge. So you got the two cables there. So this set right here, this is the voltage input for the board. Again, 24 volts, positive, negative. And then these two top lugs here, this is for the heated bed. And the heated bed really doesn't matter. This could be reversed. It doesn't have to be positive, negative. I just followed the schematic. Schematic says that this should be the negative and this should be the positive. But since it's heating a bed, it doesn't matter. It's a coil, so they can go either way. And what I did here with the CB1 is, you guys saw my previous video. I talked about that this board has a designated SPI port. All right, so if you look here, I'm using the this top 6 pins of this SPI port, and I'll include that file in the video description. That way you guys can check it out. But that's how you plug this accelerometer thing into. And I'll also leave a link to the 3D printed file that I used to make this little header plug. That way, if you guys want to use it, you can. Now, I had somebody ask me about this HDMI port here. I haven't used it, so I'm not sure if it's enabled by default. But I may do a future video on how this thing works exactly. I just haven't messed with it. And that's pretty much it. So what I can do is let's go ahead and button this thing up, and I'll fire it up, and I'll home it, and I'll show you guys that it's working. Well, let me show you something kind of cool that I found that you could do. So since these are Noctua fans, these two fans are Noctua, what I'm doing is I'm splitting the 24 volts between these two fans. And you can do these with these, you can do this with these radial type fans. This will not work if you're using blower fans. So if you got a couple of 12 volt blower fans and you're trying to power them using a 24 volt supply wired in this configuration, it will not work because there's not enough startup current to get them both going. But it works perfect for these little radial fans. And what I did is I bent these two pins towards each other and then soldered these two center pins together. And then what I'm doing is I'm putting, let's see if I can move this up so you guys can see the cables here a little bit, or maybe pull it down. All right, so what I did is I jumped the two center pins together. So I put the positive for the 24 volts in on one side and the negative for the 24 volts on the other side. And then I have, and then I plugged my two fans in like this. So these are two 12 volt fans, and you have to make sure that you line up, the proper wire with the proper side. So the 24 volt negative would have to go to one of the fan negative cables. And then on the other fan, the positive cable would have to go to its positive cable. And then what's left over is just joined together. You can either join these physically here, or you can, do it this way. I found this way is better because then I can continue to use the same plugs. I don't have to do anything on this side, and this is a pretty easy little thing to put together. Anyway, I thought I'd show you that because I like the way this looks. It's nice and tidy. Let me push this back in here, and then we'll put this thing back together. And the way the fans get held on here is so this bottom fan just pushes onto these little lugs on this onto these little pins that are on this 3D printed part. And I'm gonna, let me see, I had it just like this. You just put them down there, and you could hot glue these if you wanted to make it permanent. I'm always going into this printer, so I don't want anything permanent really. So the first one goes like this. And I recently started using these little heat inserts, and I really like them. They're really easy. You don't need any special equipment to insert them. You just have to set your model up to accept the inserts. So if you guys decide to pick up the STL file, that's the way that I have them set up, is to use these heat inserts. Before I straighten up the printer, let's go ahead and turn it on. Make sure everything turns on properly. All right, everything's working. All right, let me stand it up and then we'll test it. All right, so let's stand this thing up and test it. You guys notice that my stepper motor cables are really long, and that's because I plan to do a Kevin Z-belt mod, but I want to do a dual motor, so that's the reason why these cables are so long. So this cable is plugged into this stepper motor, is going to get moved up here, and then I'm going to add another stepper. Move this thing back so you guys can see what I'm talking about. So this stepper motor cable right now is real long, and it's going to get relocated up here. So the whole stepper motor is going to get moved up here. And then I'm going to do the same on the other side, and that's the reason why I got these super long cables. Alright, so let's turn this thing on and we'll home it. We're up, and let's home all. Alright, and that's it. So guys, if you're new to the channel, consider subscribing, turn on your notification bell, and leave me some comments. I love reading the comments and do my best to get back to you guys as soon as I see them. In the next video, we'll be installing Kevin's dual Z-belt mod on this printer, and then I'll show you guys how we can take advantage of the independently controlled Z-axis stepper motor. Alright guys, catch you in the next one. Take care.